Okay, test of assembled spindle. Spindle is running. I've assembled everything back here. Change motions. Head rotation functions. In and out. And you can set this locks the spindle tight, or you can use this lever that engages the pin to move in 30 degree step. Now it's locked in 30. There's 90 there. Unlock. Next should be 60. Yeah, 60. This way you can ensure division. Bars for horizontal milling. Paint the head, of course, test it, lube it, whatever. Back gear. Yes, it was in back gear. Now we can go up to 1600 RPM. So, some measurements before I proceed. Spindle taper here is ISO 40. Inside and outside I take measurements to have a view of the, get a grip on the run out. And then zeroing the indicator. And turning the spindle. It's in back gear. Maybe if I run it the other way around, it won't jump so much. Is it 1 there? 1, that's 4/10. A little bit on that side, so we call it half a thou. Okay, within spec. Inside of course, is more important. I think we'll swivel it like that. Lock this. So I brought it around. Hope you can still see. I'm zeroing the indicator on the internal taper. And then I rotate the spindle. So this close to zero. I can take it a little bit further in, so I won't be fooled by that gap. Like that. Yeah, that's okay. Then I can, while I'm at it, I can take two more measurements. One is head rotation, like that, on this cylinder, and then in and out. So now I zeroing the indicator, and I will rotate the head around. So let's go, and we enter into the slot where the key rides. 0.1, the key, and then is 0.15, 0.2, and then back again. 1, and it's closing in on 0 again. So I zero the indicator again, then I move the column in and out. The movement is 18 centimeters in and out. So here we go. The spindle is 18, and then I could turn the spindle around so I could get it all the way in also, but I'm satisfied. That's good enough. At least very close to 0. So the last test I will do now is to insert the spindle. Insert a holder in the spindle with the drawbar tighten. Just check if the end float. I mean, there is a cylindrical double bearing here, and then there is a thrust bearing, normal ball bearing back here. And the only adjustment is this way, drawing it in, but okay, I'll have it in back here. I'll tighten the bar. Then I will pull here, measure the deviation. I get pull downwards. And I will go up. I'll get 2 or 3 hundredths, so 1.5 thousandths each way. So question is that too much? I come around from the other side. Now you see why this is called a universal mill, because now the head is mounted directly in the in and out feed way. I can retract it as far as it will go into the column. I a little bit snug there. Oops. Okay, and then measuring again. So now it's running at top speed, almost at the lowest setting for the motor. That's how loud the sound is. I just entered it with the cable directly to the motor, so bypassed the main switch and also the circuitry for speed changing on the motor, just for testing. These are bars, horizontal milling of course, so call it end mill holder there. And from the rear, motor down there, the tensioner, there's 3 belts. I did not replace the belts, not yet anyhow. So by the way, this is the foot main casting of an old shaper, Johnny and the Norman, Swedish one. I'll use that as a welding and scraping table. Scraping then with use of this, not that one, but this vise here on top of the foot, which is the table. I'll just mount this onto the casting, then it will be sturdy and I can scrape on that.